Welcome everybody to the April 30th, 2026 edition of the Technical Advisory Council of the Confidential Computing Consortium. Today, my name is Fritz Alder, and I will be chairing the meeting. We are an open and collaborative bunch, so feel free to jump into the conversation and contribute constructively, just like you're welcome to jump into any of our projects or SIGs. And when you do that, let's remember that there is an antitrust policy, so check that out if you want to learn more about that. And
Dan, before you continue, although we don't have Ben here, may I please introduce Michelle, who I suspect still in Snowbird as well, but she is our new PMO. Renew, as people may know, is on maternity leave, and Michelle has joined us. She has lots of experience. Maybe you just want to introduce yourself quickly, Michelle, and she'll be our contact person. Michelle?
Sure. I won't take up too much time. I actually just got back home last night at like 1 in the morning, so I'm a little
Oh,
jet
well
lagged, but excited to be working with y'all. And I just wanted to join this meeting to kind of continue to get up to speed on the project. But Ben will be on PTO coming up for about 2 weeks in China and unavailable, but I will be around. So please feel free to reach out if any questions that are program management related come up. I'm happy to help and look forward to working with y'all.
And we
well,
have a
what a
new
fun
email
surprise.
address which will reach either of them, which is support@linuxfoundation.org. Oh, no, it's support@confidentialcomputing.io.
Yeah.
Sorry, that's right. Sorry.
Mhm.
Yeah. Sorry, Dan. Back over you.
No, I was just saying what a wonderful surprise. So thanks for joining us, Michelle. We're happy to have you.
Yeah, thank you.
Did anybody clue you into our Monday morning stand-ups?
They did, since we were all at Snowbird this last week, we weren't able to make the Monday one, but I will plan on being at the one this upcoming Monday.
Okay, great. Well, you're already a step ahead of things. That's fantastic.
Yeah, and if anything else comes up or you think I'm not on a meeting for some reason, just throw me on and I'll do my best to join.
Okay, great. All right, and now let's do a little bit of agenda bashing. We'll do our normal check-in on reminding ourselves what we did last time. I don't think we have any announcements exactly. New business, we have you're with us to give us an update on Coconut. Then we've got working time on the blueprints, and then I was not sure if we're doing this tech talk today, Alec. I think this was intended to be the shared responsibility model and like CSP managed devices, that
Let's
sort of thing.
let's do that next time.
Okay, I thought so.
Yeah, sorry. I had it ready to go 2 weeks ago but I just completely forgot it. I'll do it next time.
Not a problem. I think we are going to be very busy with all the blueprints today anyway. Next time we will have an update, I believe, on Keystone, and Ijlal, our vice chair, will be standing in as the rotating chair for the meetings. Any other agenda topics or future-looking things people wanted to get on the radar? Okay, I am going to be asking for a vote, I think, today on at least one of those documents. So let's see if we have full voting representation. It's looking a little bit light. I don't see anybody from AMD. Huawei. What about Intel? Do we have? Don't see Scott. Meta. No Meta. Boy, this is a bad week for people. Alec, thanks for being here. I'm here. We have Mingshen. Thanks for being here, Mingshen. We do not have Bob. And I think I skipped over Renee somewhere. Where's Google? Skipped over Renee. Thanks for being here, Renee. So we are one shy of quorum. So if people could keep an eye on the attendee list as we go, sometimes we have late joins, though we're already 10 minutes into the meeting here. So I guess maybe Jörg or Jeremy, if you wanted to ping Nathaniel or David to act or to join, that would be great.
Sure, I'll ping them now.
Thank you. Okay, and now is the time in the meeting where we welcome people like Michelle, who might be joining for the first time, or if this is even your second time and you want to make sure that people know your name. It's a great time to pop off of mute and introduce yourself and let us know what your interest in confidential computing is and where you're joining us from and how you'd like to be addressed.
Then can you hear me?
I can.
Okay, so yeah, I'm not new here, of course. I've been attending these meetings for quite a long time. Just want to let everybody know that I'm not the representative for Linaro anymore in this group. So I'm attending as a standalone person this time.
Well, great that we still have you outside of the Linaro group. So thanks for continuing to join, Leonardo.
Yeah, good to see you.
Okay, maybe I can jump in. So I'm Cedric Fournet. I'm at Microsoft. So I've been working on confidential computing for a bit more than 10 years now. I'm in Azure Research. I'm primarily a researcher in security and cryptography, but it's my first time joining this meeting, but I'm quite excited to see what's going on and to help with the technical documents.
Well,
Where are
bienvenue.
you based?
Oh, sorry. Yes, I'm based in Cambridge in the UK.
Oh
That's where
no.
I'm usually based. Oh, come on. That's not very nice, Alec.
More representation from the UK. Good to see you, Cedric. Glad you were able to join this morning. It's good to have you giving us a
Yeah.
hand here with some technical documentation and
Bienvenue.
everything else.
Yes, thank you so much for joining.
This is Cedric's first meeting here, and I've been trying to convince him that we're a very collegial group. So I'm looking to everybody to please lend support here and pulling the wool over his eyes.
We're all very friendly, apart from Alec, of course. But, sorry, Alec.
All right, let's all be on our best behavior now.
Okay, I'm convinced. Thanks.
All right, last time Alec took the reins to guide us through the agenda, so I appreciate you doing that, Alec, and the preparation beforehand. We got an update from the workload identity SIG from Mark, and then we got our annual review from Grameen, and I see Mona is on again, so thanks for joining, Mona, and thanks for the update last time. And then Alec gave us a tech talk on or at least an update on our ISO relationship. So that's something for those that weren't present for that confidential computing is going through the standards process at ISO, and Alec is our designated liaison from the consortium over into ISO.
Just to say, I've confirmed with Jory that I'm apparently the backup, Alec. I know we're going to have a chat about that at some point, but if there's ever a problem and Alec can't do stuff, I'm apparently allowed to stand in. So there we go.
Okay.
I wouldn't be doing it willy-nilly, and certainly not without consulting Alec, but apparently I have some sort of official standing there. So there we go. Oh, you're muted, Alec.
So just so you know, Mike, that's really good news. They're a super formal organization. So the fact that you are standing in official capacity is important. So hang on to that. You've probably been seeing the flood of emails from ISO as far as meeting invites and stuff. We'll talk about that offline. Cool.
Perfect. Thanks.
That's great. Okay. Does anybody have any announcements? I've got some, this is sort of more like new business that I plan to go into here, but I don't know if there's any, usually we do awareness of conference RFPs and that sort of thing right now, and I'm not aware of anything on the immediate horizon.
No, I mean, apart from obviously CC Summit, hopefully the program will be announced soon. I was on the program committee and I voted on lots of stuff, but I don't think that's been announced yet. So,
okay, great. Well, thanks for serving on that program committee. So a little bit later, we're going to work on the existing blueprints that we've got started, but I want to start getting moving on the next round of documents. So we have two documents that we are going to update instead of building things from scratch. So one of them is the original TAC white paper. That needs to be updated for things like multiple devices and other sorts of TE types and reflecting the shared responsibility model in data centers. And then there's the terminology paper that needs to be updated for similar things, especially the different kinds of devices and TEs that are built out of aggregates, aggregations of devices. So we'll be looking for volunteers on that. I guess we could even do that right now. So starting with the TAC white paper, if you go out to, just do it live together, go out to confidentialcomputing.io, and all of our published things are in the white papers and reports section. And we have, which one of it is? Here we go. Technical analysis of confidential computing. Our last update to this was, I think, to add attestation as one of the required aspects in the definition of confidential computing. But we could use an author to go through here and update things from, I think it's been a few years since we checked in on this one. So November of 2022. So we've probably had a few things elapse in the last 3.5 years.
Yeah, and I think, Dan, as I understand it, the thinking here is that this is really what in some places is called a rapporteur, someone who owns the document and encourages people to make changes and things, and maybe author some of it themselves, but it's not expecting them to do all of the work. Is that right, Dan?
Yeah, I'd like the person who volunteers to take a scan through the document and at least highlight areas that need updating.
Yeah.
And ideally provide suggested updated text. I feel like this is a little bit lower of a bar than creating a new document from scratch.
Tell you what, Dan, if we can scope this to going through and updating anything that we think is not aligned with the current vision of the TAC today, and just suggest new wording wherever we think there's misalignment, not add any sections, but just update and correct as necessary so that we can get that date on the publication updated so that it doesn't look quite so out of date, and put a deadline on it so that it's due by, I don't know, it's, middle of June, end of June, something like that, and have an up or down vote on a specific scheduled date so that everybody knows it's either going to get approved or stay as is by a specific date. I'll sign up for that.
I love that. And I think for a date, what if we try to get this in ahead of the Confidential Computing Summit? So that's what, mid-June?
I like that. That gives us the entire month of May. That gives us probably 3 meetings. So by the first meeting, let's say, I don't think there's going to be, I've read through the document in advance of the ISO meetings. It's not that it's that far out of date. Maybe we just need to reemphasize some things. I don't think it's going to take a lot of work, and I don't think there's going to be any controversy. So I'll commit to having a draft done by the next meeting, and I'll put that out there in a shared doc. No, we'll just update it in MD format, just there in Git, and review it in the next doc. Just kind of go through it. In the next meeting, kind of go through it, give people a chance to review it, and then we'll have 2 meetings to get it approved. How does that sound?
That sounds great, but you should not attempt debate by saying there will be no controversy.
Yeah, and also, Alec, I think when we say we commit to no new sections, I think we can commit to no new sections for this version, but we might also say, look, there is some future work that we do need to be putting out in the next version and sort of flag that as something. I don't think we should shy away from that, but I don't think we need to. I think if we want to scope it, that's probably a sensible thing to do. Does that make sense?
It does make sense. And here's the way I was thinking about it. And obviously this is just initial thoughts, but what I was thinking is we can try to keep this as an intro document to confidential computing. I think the new sections that you have in mind and I'm just reading your mind here, so I might be way off. But I think there's new sections that are necessary to explain composite devices, as Dan was alluding to earlier. That probably needs to go into the technical, not the technical analysis doc, but the
Terminology.
terminology doc
Yeah.
or another doc. So maybe as we're going through this doc, we can capture ideas and suggest chapters for
Yeah,
another
I, I,
doc.
I I love that. From my point of view, Dan, I'm presuming that sort of fits your thinking as well.
Yeah,
Brilliant.
that sounds great.
Love it.
All right. Well, that was easier than planned. So how's about the terminology doc? So this one, December. So we did this, I guess, right on the heels of updating the white paper. So the terminology documents does not reflect things like GPUs and smart NICs and that sort of thing. So that's at least one of the updates that has to be made to it.
And the
Would you want to
containerization.
maybe,
The
yeah,
containerization section is a little thin too. I know there's a lot of work that's been done on containerization since the
well, we
stock was
have the
published.
coconut thing coming, right? So I wonder whether we should leave this one until we've done the initial work on the other one, because as Alec mentioned, we may be suggesting new sections for this. Or
That
do you
would be
want to
fine
try and
with
get
me.
things going?
Well, I wouldn't, if somebody wants to volunteer to jump on it today, they can start to get a sense of the scope and then they'd be prepared to help guide that conversation. So if there's somebody who particularly likes to work on ontologies and kind of getting into the details of what constitutes a trusted execution environment, different ways to distribute software that are TEE aware, this would be right up your alley.
So
No,
so
I'm
let's
jumping.
let's do this, Dan. Give me a minute to work with my new colleague from Microsoft and help introduce this document, and maybe I can do some recruiting. But this is going to take a community effort because there's a lot of content here that has generated controversy in the past. I don't mean controversy, I just mean uh, it's difficult to define, right? So choosing words is hard and it takes a lot of time. And if you go down, I don't know, to page 4, I think, or maybe page 5. Yeah, the next one. This one here. This
Mm.
is, I think, there's a lot on that graph there, and there's a lot more on that graph there when you start talking about confidential devices. We maybe need to skinny down the SGX parts and add a little more heft to the, um, you know, TDX, SGX, I mean, sorry, TDX, SEV-SMP, CCA sections. Um, so this is going to take a lot of rework and new content. So maybe we can make a whole working meeting just around suggestions for what the new outline could look like, and then maybe get people to sign up for individual sections. But to take on this whole document is a lot.
Okay.
That's just me talking out loud. Sorry. Obviously, everybody should weigh in here. I just having read it recently, very recently, it's a great doc, and it just needs and it begs for a little bit of TLC.
Okay, well, I like that. That's probably more practical approach to getting contribution, like we can kind of divide it into pieces. Though I will not stop somebody if somebody wants to be the ringleader and kind of orchestrate all of the different sections that need to be updated.
Mm.
So we will let's get into that again next meeting, and if I remember, I will send a note to the list so that our other colleagues who aren't present here can start thinking about volunteering for that.
So if I can ask a question, so I had a look at those documents and I discussed it a bit with Alec. It seems to me that there is some fresh text that needs to be written about how to incorporate devices and how to have sort of composite platforms or composite attestation. And that is fresh content that is more focused work. And I'm wondering what is the right place to start working on that? Is it the technical architecture? Is it the terminology, or is it a new document? And the idea was that to stage it, either we do the refresh without doing that, or we first write something about devices so that we have the technical details in place, and then we can write something that is aligned with it in the terminology, for example.
That's a good question. I could imagine it's being a separate document or additions to one or both of these. I think it kind of depends on the amount of content. I think for our sort of intro technical piece, we don't want there to be huge sections in this. We want this to be, you can complete this document in one sitting kind of thing. So short pointers to confidential computing capable devices exist, and they are a regular part of confidential computing. Just a few sentences would be how I would approach it for this document. Terminology document, you could have new paragraphs or chapters. And then if you had in mind something that had a lot of content, then we could even have a CC devices document. I don't know off the top of my head what kind of outline that would be, but if you have that in mind, or you wanted to sketch that up ahead of a future meeting or throw it out to the mail list, those are all different ways that we can kind of brainstorm on where the right fit is. From a mechanical perspective, one of the things that we do that you'll see in a little bit with the blueprints documents is we usually start with like a Google Doc where everybody can just kind of pile in. What works best is if somebody creates a first draft and then other people kind of treat it like clay and take out sections, add in missing things. And then once we arrive at something that's more final, then we have our governance repo where we can actually put it into version control. So like the terminology material is in Markdown here, along with the source images and the renderings into JPEGs. The final output into that PDF is something that we sign up LF Creative, the Linux Foundation Creative Department to do, and they'll do like a nice layout into a PDF. But sort of the step right before that is, or in parallel with that, is putting it into source control.
Okay. So pragmatically, for the terminology, are we going back to the Google Doc, or are we going to work incrementally on top of the Markdown?
It might be easiest, given the amount of work that Alec was alluding to, if we kind of take the Markdown and throw it back into a Google Doc and then bash on it for a while and then bring it back into Markdown. That's one approach. Otherwise, we could do it as pull requests onto the original Markdown.
And Dan says bash, but of course Z shell and other shells are available if you wish to use them. So we're very open.
That was terrible.
Sorry. Thank
you. Okay.
It says Z shell rather than Z shell, though. I'm proud of myself for that. Sorry.
For those of you that haven't used the born again shell because you weren't born in the Pliocene era, as were some of us, that was actually a pretty good joke. I'll say, Cedric, since you're new, the use of shared documents online like Google tends to work better because not everybody's familiar with Git and the Markdown kind of review process. It's super easy to just go in there and point and click and type your opinions. And then if somebody has good wording changes, you just click update, and it's easier than managing merges and stuff. So that's what I'd recommend. As I'm in alignment with Dan in saying that just dumping everything into a Google document and then giving people shared access works pretty easy mechanically. That's what I'm going to do for the thinking about it some more. That's what I'm going to, especially since we've got Linux Foundation to kind of wrangle it back into a PDF format. That's probably what I'll do with the case for case for confidential computing, but the original document there.
Okay.
Yeah, I think the original technical document is kind of borderline, but because shouldn't be that many changes, but certainly to the bigger document, we're going to be adding stuff, and people are going to have lots of opinions they want to comment on as well. It says those two together. I agree. That's probably better.
Great. Okay, well, I think that was a great discussion, and our priorities then are to help Alec move us forward with the technical analysis document ahead of the Confidential Computing Summit. And then in parallel with that, but not with that same deadline, make some traction on the terminology document. And with that taken care of, let us get Jörg onto the stage here. So I'm going to stop sharing. And Jörg is one of the maintainers and the creator of the Coconut SVSM project. And we will be looking forward to an update presently on that project.
All
And
right.
as he's getting going here, just quick reminder in the governance repo, I guess I should have pulled this up beforehand, but there's a standard set of questions that we go through to make sure that we are providing the right kind of consistent oversight for projects, and I will dump that into the chat. But I want people to focus on what Jörg has to update us with right now.
Okay, thank you, Dan. So yeah, happy to be here and present the project update for this year. I want to start with the project mission because there's a slight change. So the mission of the Coconut SVSM project is to be a platform to provide secure services to confidential workloads. If you have seen the mission in the past, you probably have seen that it used to be services to confidential virtual machines. Recently, and after some discussions and realizations, we changed that to confidential workloads because we want to extend the project scope a little bit beyond being a service provider for confidential VMs only. More on that later in this update. First of all, I want to get into the because this is important for the things I'm going to talk about. Talking a little bit about the operation modes of the SVSM. So we have the SVSM mode where Coconut is solely a service provider to a VM. The VM only talks to Coconut when it wants to use its services. Otherwise, it's talking to the hypervisor directly. This is the current mode of operation and still requires an enlightened OS. Then we have the paravisor mode, which is on the roadmap for quite some time. Where the SVSM actually acts as a proxy between guest OS and hypervisor. And actually supports guests with almost no enlightenments for confidential VMs. And to extend our scope, we are actually now looking into a mode where Coconut runs without any guest OS. As I said, more on that later. So some development highlights from last year. So we added quite a few things. So we added VirtIO support for PLOC and most recently for VSOC, which is pretty exciting. We extended our attestation support with a KBS support. So we now have an infrastructure where the SVSM can talk to an attestation proxy on the host, which then connects via network to a key broker service to send a hardware attestation report. The KBS server will then verify that attestation report and on success sends back a secret to the SVSM, to the proxy, and the proxy will send it to the SVSM, which is needed for basically persistent support because we want to have persistence for the services that we provide, like the TPM. and also UEFI variable store, which is on the roadmap. So yeah, so we added support for that. We added support for kernel threads, which is a segue to support for user mode threads as well. We had debugging improvements, core kernel improvements, and yeah, other CI workflow improvements, security improvements. So this were more or less the highlights from the last year. Oh, yeah, we also had a lot of boot flow improvements, which is pretty great because it will going forward allow us for some simplifications in the code base. Some development statistics. So we merged 755 non-merge commits in the last year, which is a 5.5% up from the last report. We did 267 merges, which is also an up from the year before. We added roughly a bit more than 20,000 lines of code. We had overall 25 contributors in the last year, which is an increase of over 10%. And the total contributor rate is increased by over 20%. So we have today 39 contributors to the project. And what is also great to see is that we still have a good company engagement. So we see developers from various companies working on the project. So like AMD, Google, HPE, IBM, Intel, Microsoft, Red Hat, SUSE, and more. We've also seen some engagements from the research crowd. So we have university people working on the project as well, which is also great to see. We started doing releases last year. So this started in August 2025, where we started to do development releases, usually at the end of every month. So just yesterday, I released the April release. These releases serve as a development checkpoint, usually so that when a bug or problem shows up, then we can say, okay, this problem appeared between, I don't know, February and March release, or this feature was added in the April release, something like that. This is the reason we added it. The releases get enhanced testing. So more testing than usually happens before merging a PR. But we do not do any fixes or stable backports to these because they are just development releases for now. Yeah, and we do signed release tags, of course, so that people can be sure that it was me that tagged the releases or one of the TSC members. Right. Next thing, we did quite some effort to improve the OpenSSF scorecard rating. Most of that came from various project security settings on GitHub, but also a number of improvements need to happen on our CI because there was some real problems which I wasn't aware of that the OpenSSF scorecard found. So our CI ran with too much permissions, and we had unsecure project dependencies. So we got to a score of 8.8 currently, and we want to improve that further. There are some things we can still do to further improve it, like better document our security process and a couple other things. So much for the status. And now I want to go into a quick development outlook for the project. So this is a modification of a slide I also showed last year in this update. This is actually the full virtualization stack of a CVM with Coconut. So we have the hypervisor, we have QEMU, we have the CVM which runs Coconut at the top, at the bottom, then OVMF, and then the Linux guest, and all the And on the right side, you see all the pieces that we need to implement, and what we have actually done. So from the past year, there's an improvement that we implemented the QEMU IGBM support. This is now upstream, and we also have the SVSM memory region detection, which actually makes the SVSM more flexible in the memory it uses in the guest, which is currently still too static. We want to see at runtime how much memory the SVSM actually needs, because that depends on the number of vCPUs the CVM has, besides a few other things. So this needs to be more dynamic. So the biggest missing piece is still the Linux KVM and QEMU support for KVM planes. For those who are not aware, KVM planes is a feature of KVM that is about to be implemented, which supports privilege separation within a virtual machine. So this means unencrypted virtual machines, but also confidential virtual machines. So this is a feature that will be the front end to certain hardware extensions for privilege separation, like Intel TTX partitioning, AMD, SCV, SMP, VM privilege levels. Then the ARM side has a plain support and hardware for CCA as well. And on the non-confidential side, there is the virtual secure mode for Microsoft Hyper-V that is also planned to be supported by this extension. And to get all of this under one umbrella has some challenges, let's say so. So it needs some work, and this is currently underway. We hope to make significant progress on this during the rest of this year.
A quick question, if I may, Jörg?
Yeah, sure. Jump
So
in.
just go back to that previous one, if I may. Yeah, just a question on the architecture side. VTPM, is that an entirely virtual one, or is it one which is tied to the hardware TPM? Because V is sometimes used in both use cases, in both, to define both things, and I just wanted to understand which one you support, or maybe both.
The VTPM in the SVSM is not tied to the hardware TPM. It is actually tied to the security processor of the AMD VM, of the SCV SMP VM right now.
It's that type. Okay, yeah, I'm with you. Okay, that's really helpful. Thank you. That's all. That's all I needed to know. Thank you.
Yeah. Okay. Right. Right. So I talked about plane support. This is the last biggest missing piece for upstream adoption of the project, because it's actually a requirement to run Coconut SVSM on an upstream Linux stack. I already said it's a major architectural enhancement to KVM because it needs changes of KVM core data structures. We're currently developing it. I have a POC ready based on Linux 6.17, which is already out of date. But I hope to have a new version ready soon based on 7.0 or 7.1. So let's see. As I said, the plan is to have this merged or to make significant progress on it during this year, and hopefully have it merged as soon as possible. The next biggest important work item we have on list for this year is support for persistence. Persistence is needed to actually save state across boots of a CVM. So, for example, to store the VTPM state, which is a requirement to actually be able to use the VTPM for disk encryption, like Linux Unified Key Setup or BitLocker. But other services needed as well, which we are planning to have, like the UEFI variable store we want to implement. So they all need this persistence support. We have a PR pending for that, which is CocoonFS, which is our approach to integrity protected and encrypted file system, which is currently under review. A new version is expected soon. So yeah, we hope to have this merged also later this year. So Cocoon FS is actually the last missing piece here that we need. We already have the block device support with .io block, and we have a block layer support. We have so the file system is really the last missing piece here. So then we want to enhance Coconut to be able to act more like a parallelizer. That these are roughly the features we need for that. What we already have is user mode execution. We have user space memory management. We have a RAM file system, so not a persistent one, but a memory file system. We are working on persistency. We realized that for a parallelizer, we also need preemptible multitasking. We need timers and timekeeping support. We need a host communication interface because, in a parallelizer world, the SVSM is the proxy, so it needs to talk more to the host. So we need a host communication interface. Yeah, Mike?
Yeah, sorry, I've get to the end of this slide. I've got a couple of questions, but please go to the end.
Yeah, I'm basically through with that slide. So
yeah, so I mean, two things which may be irrelevant. The first one particularly is: do you need to add support for migration, or is it something that is orthogonal to the work you're doing? You talked about persistence, and I wondered whether there's work that needs to happen in order to allow migration.
So the SVSM can play a role on architectures, on confidential computing architectures that do not support CVM live migration itself. For architectures that do support it, like TDX partitioning, for example, or like TDX. It's, I mean, on Dutch architectures, the SVSM can play a role as some sort of migration agent to basically help in the negotiation between source and destination whether the migration should happen.
And do you already do that, or you're planning to do that?
That's actually the plan to do. So to have the SVSM assist in migration scenarios. So yeah.
Good. Excellent, thank you. My other question was, and again, this may be orthogonal to your plans, but we do sometimes hear people asking for things like constant time crypto, which may or may not be something that you feel could sit in your layer. And if it doesn't, that's fine. But I wonder if it's something you thought about.
Say again, what kind of crypto?
Constant time crypto, because there are still side channel attacks that could affect that. But if you're providing anything at that layer, or you could shim it, this might be a place to put it. But I'm not sure.
So for crypto support in the SVSM itself, we are looking for a solution where we can have a single crypto library that works with every component of the SVSM. And of course, one of the design dimensions there is also to be not vulnerable to side channels, and that also includes timing side channels, right? So we don't have a full set solution for that yet. Not even we have some ideas, not a full plan, but this is still under discussion how we are going to solve that.
Perfect. It sounds like you're thinking along interesting lines. That's brilliant. Thank you.
Yeah. Okay. So this slide is actually a segue into the next slide, because if you look at this set of features that we need for parallelizer support, then you realize that the kernel features we need for parallelizer support are almost enough to allow Coconut to run generic workloads. So the question came up: why do we, for certain types of workloads, why do we need a guest OS? Can't we run Coconut? Can't Coconut run the workload directly? The benefits would be that it's of course a very small footprint, only having basically an IGBM file which contains your full workload. It makes attestation easier because everything is loaded via the IGBM file. So you get full attestation via your hardware attestation hash and hardware attestation report. So we are looking into this with the goal of providing a subset of the Linux system call interface for SVSM userland. The goal is not to run every Linux application. The goal is to use the Linux developer toolchains to develop workloads that can run in Coconut. This also makes it kind of independent from Rust. The workload then do not need to be written in Rust. They can be written in any language that can be compiled to a binary, and works with the Linux system call interface. And we are currently investigating other open source projects to help with this. So there are some projects out there which might be very, very helpful.
You might want to look at some of the work that we did in NARCs quite a long time ago about providing syscalls directly. It may be, again, orthogonal, but might be worth having a look.
Yeah, right.
And it's all in Rust as well.
NX is worth looking at. There are also a couple of other projects. So yeah, this is something still on our research list. So
Jörg, you are looking at Grameen as well, right?
We looked at Grameen.
Or I mean, you said,
Grameen, yeah.
Is it one of the projects that you're looking at? What projects are you looking at? That's so because we can help. This is exactly what Grameen does with Grameen TTX. So yeah.
Yeah. Okay. Yeah. That's so. I watched the recording of your presentation 2 weeks ago and realized, and there I learned that Grameen actually supports TDX. I thought before that it's only SGX, but now that I know that it supports TDX, it's also much more interesting because Coconut really needs a ring 0 to run, right? So yeah.
And so I think So we should chat because I think anything where you're not running full Linux, it's still going to need certain, depending on the workload. Either you run very minimal workload where it doesn't need, say, a network stack or a file system or whatever, then it does need support from maybe an untrusted OS. And in case of Grameen, we have this idea of a POVM, or we use the host OS. But also you can run certain workloads that don't need, that they can just run in Grameen without any host support. But this is something I think the two projects should talk before you sort of at least not reinvent the wheel, right? And see how we can leverage the two projects.
Yeah, right. Yeah, let's get in touch on that and talk about it as we make progress on our plans for that.
Sure. Okay. Yeah.
Yeah. Thank you for bringing that up.
And I will say, as TAC chair, that if we had two CCC projects working together and integrating, that would make my day.
You're not alone.
Yeah. Okay. Then let's go. Oh yeah. Next thing. For the Outlook, we are for the first time participating in Google Summer of Code. The QEMU project, which was kind enough to host us under the umbrella. We have two projects submitted. One is support for observability, and the other one is PCID and CPU to add PCID support and improve CPU ID handling, which is kind of messy right now in the code base. Observability is about having an interface for the guest OS to actually get observability data from Coconut, like the boot log, for example, or memory management statistics, things like that. But this is work that requires a new SVSM protocol and a Linux side driver and Linux side userland. So yeah, we are planning to do that as a Google Summer of Code project. We're currently awaiting acceptance from Google and hope to bring new people into the project via this. Let's see how this works out. It's a first time for us, so yeah, we are looking forward to the experience and whether it works out. So So with that, I'm getting into the last part of my update, which is about the Coconut community. I'm happy to report that we still have a stable and broad community. We still have our weekly community calls, which are usually attended by like 10 to 15 people. There are regular meetups, not really planned meetups, because not everyone attends all events, but there were people from the community meeting at FOSDEM, at PC, and also at OC3, and there were conferences and sessions around Coconut at all three of them. So from time to time we get to meet. Then the governance hasn't changed much since, basically hasn't changed at all since last year. We still collaborate via the GitHub infrastructure. We hold the weekly development meetings. Besides that, there is also a weekly technical steering committee meeting for the technical steering committee, which is still the same as it was last year. So we have 4 people in it. We have a project mailing list. We have a matrix chat room. Yeah, and I already mentioned the TSC. And with that, I'm getting to the end of this, and want to thank the community for the work they put into the project and still putting into the project. That's really great to see that the project is thriving with its community. I also want to thank the members of the TSC for their work in helping with the maintenance of the project. The weekly meetings are very helpful. We discuss project direction, we discuss PRs and issues and things, and it's really helpful, and also puts the project on a more stable base, because it removes me as a single point of failure of the project. So, and of course, I also want to thank the Confidential Computing Consortium for all the support we get, and for hosting us as a project. And with that, I'm at the end of my update. And yeah, Mike, you have a question?
Yeah, no, this is all fantastic, and congratulations on keeping things, moving and increasing. I was particularly pleased to see the number of contributors going up, I have to say. I just wanted to know where you are in terms of, and I'm sorry if I missed it, I had to drop out just for a sec. In terms of usage and maturity of the project, whether that's something that you're ready to move around at all. That was my first question.
You mean project? So you're talking about project adoption, right? So this is so Linux distributions are starting to packaging the SVSM. Of course, they cannot really ship it yet, because the KVM host and QEMU host part is still missing the plane support. They can only ship things that are upstream. And for that, we need the KVM plane support upstream in both KVM and QEMU. So this is what we see, and one of the cloud service providers also has an SVSM based instance in preview right now. That's all, and that's another adoption we are currently seeing.
That's very helpful. I'll step back. Sounds like it's not time yet.
Yeah, Alec?
Yeah, you mentioned Cocoon FS as some sort of an integrity protected file system. I've searched online. I don't see anything about Cocoon FS. Is that something that you folks are developing? And if so, can you describe it? Is it some sort of Merkle tree based integrity guarantee for file system access?
Yeah, it's actually something that is developed within our community from developers at SUSE. It's a Merkle tree based file system. So there's a Merkle tree for integrity guarantees. Actually, the root hash is actually the proof of file system integrity. The file system does not support file names. They only support inode numbers. So you have to assign, like, I don't know, inode number 1 is, well, I know the first number of inodes are reserved, but I don't know, inode 10 is VTPM and inode 11 is UFI store, whatever. The focus of the file system is actually security and not performance. So, for example, it uses AES GCM, I believe. So every time you make an update to a file, you need to rewrite the whole file because you generate a new IV and then this propagates over the whole file, right? So if you want to make an update, you need to write the whole file, and if you want to read something from a file, you also need to read the whole file up to this point where you want to read. So, but I think for the workloads we are looking into, this is fine. We built in an option to extend this in the future to maybe support random reads and writes if we need it. For VTPM and variable store, we don't need it. I think for those, it's fine that we always read and write the whole file. But yeah, there will be a possibility to extend it in the future. So yeah.
Got it. So I was going to ask if it supports writes. It's cool. So you got a full-on read-write file system. Yeah, it doesn't support. It's not a general purpose file system, but it's a read-write file system that'll work to support updates to UFI state and updates to VTPM state with full integrity and confidentiality built in.
Right.
Awesome. Cool. Thanks. That answers my question. I don't know if I mean, I'm Microsoft, so I have to put in a plug. Don't know if you've seen anything about the REFS file system that's on the Windows side, and it's a general purpose file system, an OS user level file system that also supports integrity. Trying to figure out the Linux equivalent, which we haven't figured out yet. So I might reach out to you and ask about this.
Yeah. Yes. Okay. I have not heard about REFS yet, but yeah, I will look it up and read up on that. So yeah, for Cocoon FS, there's a long specification. You can I can probably send you an email with a link to that.
I'll put my email in the chat. I'd love to see it.
Yeah, it's a rather long Markdown file. So if you render it into a Word doc or something, it's like 40 pages. But
if there's a GitLab link, that would be great.
Yeah, I dig it out and send it to you.
I'll keep looking. I just didn't have any luck at all with Cocoon FS. It's not something that web searches are helping me with.
If you look at the Coconut SVSM repository and the pull request, there's the Cocoon FS pull request, and this is basically the PR we have pending, and this probably from there you could probably get to I think this links to the Cocoon TPM repository actually, and in there is the implementation of that.
Cool, thank you.
And also the specification. So
I've got a couple more questions on that. So first of all, feel free to post that to the TAC list, and that'll hit Alec and everybody else who might be interested. Typically, file systems have been difficult to protect against rollback attacks, and I wonder if you've got any fixes for that. And then there's also the Lux file system, I think, for Linux that provides different sorts of like integrity and encryption capabilities. So I'm curious if that was ruled out because of some weakness that we should be aware of.
No, it was not ruled out. So Lux was not ruled out of weaknesses because of complexity. Okay. So with Lux, you have to basically stack your features, right? You have Lux which is basically a gateway to de-encrypt, to get your de-encrypt key, which gives you encryption but not integrity protection. So for integrity protection, you need something else. You need something like DM Verity. And when you have that, I think you get into problems with writability. So yeah, it's not as easy as it seems, and can get very complex if you want to copy that over. Coconut aims to be a rather small project, so and Cocoon FS really has all of that included. It has encryption, it has integrity protection built in. So it's just one layer of things, and not like with a Linux-like layer, we would have, I think, at least 3 layers. We would have the encryption layer, the integrity protection layer, and then the file system layer on top. So, yeah.
So as a follow-up question about integrity and freshness, how do you guarantee rollback protection between restarts of these on the machine? Is there a mechanism to guarantee continuity when do you lose the state of your protected memory.
Yeah, so rollback is only possible with the whole file system, so not with individual parts of the file system.
Okay.
But besides that, we don't have protection yet. We discussed this a couple of times. We don't really have a solution for that. How to protect against that. One idea I had was with the observability protocol that we have, or that we are going to implement, basically expose the root hash via the observability protocol to the Linux OS, and then Linux can basically either get an interrupt when the hash updates or changes, or regularly fetches the hash and saves it, and this way detect whether there is an old hash or something like that. This would not be a full protection, but it would make the problem smaller at least. But yeah, full rollback protection we don't have a solution for yet.
And your business thing, Grameen does the same. So as long as you're running that instance, we save the root. You can get the rollback protection, but across we don't have a solution because we have no place to sort of save that root hash. So that's just sort of an open problem across in confidential computing. But Grameen does also have an encrypted file system, and I put the link in the chat here.
Okay, thank you. I will have a look at that.
I've got another question if nobody else does. Make sure we make room for everybody's questions here. Thank you for introducing me to the planes feature in KVM and QEMU. I was not aware of that. I know that ARM's CCA has a planes feature. Do you know if there's sort of an intrinsic similarity there, like that one was that maybe the QEMU one was initiated because of the CCA feature, or just maybe similarity in names that there's not really a relation?
Yeah, so this name came actually up in a meeting at KVM Forum 2 years ago, I believe. The KVM maintainers thought about a name for that. Obviously, we couldn't name it VMPLs. We couldn't name it anything on the x86 side, though they chose the name from the ARM side, and now it's called KVM Planes, which is at least in QEMU a kind of overloaded term already. But yeah, that's what they went for. So we are now calling it Planes. So
okay.
Yeah, the plan is to also support ARM CCA planes, but the planes feature itself is for x86 as well. So, and for all other CVM hardware architecture that support privilege separation in the future.
Okay, thank you.
I have another one, if I may. Unless anyone else, I don't want to crowd people out. I do that. So thank you, Dan, for stomping on me. Stomping's wrong. Anyway, I was very pleased to see that you've been using the OpenSSF scorecard thing. That's really good to hear. Have you looked at all at the question of CRA, EU CRA management? Again, if you're not actually being fully adopted yet, it's not something you need to worry about quite yet, but at some point, if you're looking at that, all confidential computing projects should be thinking about whether they need to have an official open source steward, via the CCC and the Linux Foundation. So if you're not aware of that, very happy to talk to you about that, but you will have to be an organization who do. So yeah, please think about that as we move forward.
Yeah, you said ECRA. What is that?
It's the EU Cyber Resilience Act. So it imposes lots of regulations on anyone using any code basically in the EU, including open source code. And if we want to make it as easy as possible for people to build products which use Coconut SVSM or Grameen or any of the other projects which are part of the CCC DStack, whatever, then just making sure that we know what's going on there is something that is very important. And I spent quite a lot of time doing this sort of outside the CCC, and it's something that I'm very happy to talk to people about if they have any questions.
Yeah, okay.
Dan, if you want me to do another sort of brief sort of 15-minuter on EU CRA and the impact on projects and stuff at a future TAC, I'm very happy to do so. It might make sense.
Okay.
Yeah, I'm interested in that. I'd like to learn what we can do to make Coconut a fit for those.
Yeah, perfect. That's exactly the sort of thing we should be thinking about. The fact that you're doing the OpenSSF stuff is a really good start, honestly.
Yeah, okay.
Scorecard, yeah.
All right, well, that seems to have run through the questions. Thank you for an excellent update and for continuing to guide such a vibrant project. It's great to have you in the CCC ecosystem.
And thanks again for hosting the project. It's really helpful. We use the resources from the CCC, and it's great to be part of this group. So
wonderful. Great. If Coconut gets together with Grameen and they have a little CCC project baby, that would just be fantastic too.
Yeah, let's see.
All right, but I'm sure you both projects will do whatever is right for the project. So if that works out, great. That's the same. Okay. All right. Let us move along to the next subject, which is we want to get into our documents. I mentioned over the mail list that I believe that the 3 degrees paper is ready for the final check mark here. So let me get my screen to display again. So I'd like to do just one final pass through. We had the final set of feedback, and I think I've addressed everything. So I just want to make that concrete with the community and make sure that I have addressed things how people wanted. First of all, there is inconsistency in the graphics, just the styles of them. So I went through and I updated all 3 graphics. So now they all have a consistent look and feel. And I tried to use the color scheme as best as I could extract from the CCC website and our slide deck. So they are similar. One question I have, so one of the overall goals of this is when I've interacted with people, they think that all of the work happens on the server that you've turned confidential computing on. And there's not really a recognition that these other systems that don't operate confidential computing themselves, that they have an integration role. So things like the key management server or having an explicit attestation server, these other parts of the infrastructure. So what I really wanted to do was shine some light on that part of the adoption cycle. And so I've got 2 alternatives for the first graphic. I can both fit them on. So first of all, it's the same picture as what has been on there from the get-go. It's just I got rid of the dark coloring. So the look and feel is different, but structurally they're the same. So in the first option, this is basically what is on there now. And the second option, just to make clear that we're adding new systems in, I removed that from the first picture. I don't know if that makes a difference to anybody. Spent all Saturday looking at the same diagram for hours and making little tweaks. So nuances mean a lot more to me than probably anybody else looking at this. But if the goal is to communicate, we need other systems besides the server that is operating the workload. I don't know if people have a gut feel for one or the other, for A on the top or B on the bottom. All right, so I think probably nobody cares. So I guess I will.
No, Dan. So no. So the only difference is you just are showing that key repo in the bottom, right? I think that's better because you're just saying it's off somewhere and you actually have to use it or something, right? Is that what? Because in the first one, it seems like, yeah. So the second one, that's the only difference. If I was just trying to closely look
that's
at
the only
it.
difference is I removed this block from the first one just to try to make clear that it.
So you removed it. Okay. I thought you okay. So I thought you added. I think it should be there, no?
Okay.
Okay. Maybe I don't know what others think. I actually like the bottom, but it's there. And the second one, you're just saying it's there, but it's unless you use it, it's not very useful. That work has to be done, right?
That's the goal.
The second picture. But in the first one, yeah, I guess you're saying it's possible to just use it without any key repo. Is that if you remove it?
The idea is that you turn on confidential computing on the workload server, and then you integrate attestation with some backend, and then you deepen the integration so that you're identifying the workload itself and making policies that are workload specific.
Okay. So then it's fine. You can remove it. Yeah. Okay.
So it shows the 3 degrees, right? But the first one, as the keys are not actually used, or KMS is not used in the first one. That's why so just removing, but it just doesn't look as nice as the top one. Just looks like a lot of white space, but the bottom more consistent, even though it's not used.
Yeah, I sort of am gonna take the opposite view here. I think the fact that it's not showing it really makes stark the difference between server integration and infrastructure integration. So I like the fact that it really forces you to think about how come you can't look at the disk in that first drawing? Why is it missing? To me, that helps. So but that's just one person's opinion.
Yeah, just highlights the difference even starker. Okay, I can see that. Yeah.
I mean, both are correct. I don't think it matters. But if some people like the first one, it's okay.
Okay. I don't want to spend too much people's time on it, but
you've thought about it more than us, Stan. I think you probably get the vote on which we use.
Yeah. So I'll either come back to that after people have a little background thread going, but I'll just kind of go through and talk about the other changes. So one of the other things was talking about these 3 levels as like culminating in the third one, and then that's the entirety of confidential computing, and people didn't like that, and there's a lot of other different more advanced uses than just getting to workload identity. So I made a few different changes to reflect that. So it no longer says finally the journey culminates. Instead, it's you've gotten a baseline adoption. So that's in a couple places, also at the end of the document. So there's these comments from Ijlal that were sort of related to that. And I just kind of scroll here. So this is the other one that was left by Yulia and Manu. So rather than get in, they were asking for maybe even get into 5 levels, but I want each of these documents to be not overwhelming to somebody who's just trying to figure out, do they care in the first place? So all those updates anyway have been made. So I will mark these as resolved. And there's another thing, ultimate decision replaced with baseline. And some more of the wording here. And then here's the picture change. So one of the little changes that I also made is that it talks about guest kernel measurement instead of operating system, because it's a little bit misleading, because most implementations don't actually measure the entirety of the operating system, and everything that's in there, you have to go through that special effort in order to get above that line and measure things like runtimes and middleware and ultimately up to the workload. And this is addressing the visual style from Fuchsia. And that's another completeness thing. All right, so I'll go through and clean up the rest of, accepting the rest of the changes. I wanted them visible for people wanting to look at it right up to the start of the meeting here. So with that, do not have quorum, but I think maybe what I'd like to do so that we aren't chasing people on email as well as in meetings.
Dan, sorry
Yeah.
to interrupt before you accept. So I added I got to this document late, and I just so maybe I'll quickly describe my comment here, and then you can decide how you want to. So this goes to, when as you describe the document, seems like this is just really focused on the big limitation is attestation. If you just sort of run a CVM, you don't do attestation, it's no good. I am just saying that's not the only limitation. And then I realized there was a bit of a discussion on this later from other people as well, right? The whole issue that came up last week when I presented Grameen, and even today, that we need these lightweight CVMs, right? You are not protected from a buggy workload and that whole TCB guarantees. I think someone else had also mentioned it later. I can't remember. I saw that comment later. So I was initially saying, hey, we need to add level 4, 5, but other people's level 4, 5 was something else, multiple workloads running in a CVM, right? I was pointing out to something else. But I think what we need to probably do is we just add another limitation. That, or the guarantees, you're only protected against like a privileged VMM or super user, but you're not protected from a buggy workload. When you're running, and then this whole problem of, like, we say, hey, you can do the attestation, but to be able to even figure out good known values for such a large system is such a complex process. I know we have these logs or whatever, there's work going on in that space. That's a huge challenge. Like we say, you can do attestation, you can exactly know what you're running in there, and it's just so hard and nobody does it. So I think we have to highlight those limitations, not just saying, first of all, they must integrate attestation. I agree, it goes in a different document, how hard it is to actually integrate attestation, to know what's good and make any sense out of it. But then we should also say the other limitation is, your security is limited by what you put in that CVM. If you put buggy code that leaks, we can't protect against that. Confidential computing cannot protect. And that's a huge limitation of CVMs today. We cannot shove it under the rug. This I think is an important point. So maybe we should just add it as a limitation. In all of them, the limitation will be there in all of them. This document doesn't address it. The only way to address it to not put this millions of lines of code in your CVM. So yeah, I don't know what others think.
I just put that somewhere, but I might not have. Let me just skim this.
No, I remember that you have it because you responded with that to my comment. So if you scroll up to the place where Mona put the comment, it is. So you're saying stop here. You're saying consequently, the workloads remain vulnerable. No. So I remember that you put that if there is a vulnerability in the code, it would not protect against that. look for
Where is
that.
that? Okay.
I remember that I read it just today. Continue.
Yeah, I found those
Yeah,
comments
yeah,
later,
yeah,
but I
yeah, yeah,
don't.
yeah, yeah,
Yeah,
yeah, yeah.
but that's
Yeah, I think that you've been there, but it could
Yeah,
be
here.
There you go.
again, transition the workload and transparent going to be
exactly.
introduced with the trusted workload.
Hmm.
Yeah, but I mean, that's not enough, right, Dan? I mean, people will say, oh, yeah, it's not just the workload. It's the workload, the operating system, the firmware. If you're just putting this huge body of the code, you're really slightly better than a VM. CVMs are really not giving you that much more. So we have to be somewhat clear. I mean, we have to add to that it's not just the workload. It's the whole thing in your CVM. So we can say it's susceptible to vulnerabilities in the workload, the operating system, the firmware, and just somewhat we have to be more explicit about that.
Okay, so let me think here. So we have the caveat up top that we found that is like the workload itself, you're not protected from your own workload. And then in here, let's see here.
No, you can just say workload and operating system and firmware or whatever, something like that, whatever the term you're using in your picture. It's not, I'm just saying it's not just the workload. It's everything that's running in a CVM. Right? So you can just extend that sentence to say you're not protected from vulnerabilities in the workload and operating system and firm, whatever term. Do you have that picture? I think in the picture you are showing, you said something about.
I think that this is true for both level 1 and level 2, and in
That's what
level
I'm saying.
3, level 3, if you are hardening the entire solution from the bottoms up, like having a minimalized kernel and hardened kernel and stuff like that, you get to reduce it. Yeah, I get your point. Exactly.
You get to reduce it, but it's a problem in everything, in all of them. But you get to reduce it. But I think that's the point. That's the whole point. That means we need to work towards a system where it's a scale, right? It's a sliding scale. The larger the code, the lower the security, minimal. And I think that's, and I'm just saying we just have to mention it. It's not that a lot of people won't care and some will care. As we heard other day, Alec was saying Signal really cares, others don't. So
we've got this visually here that
application. No, but I think exactly.
It's not only when it's not measured, also when it's measured, it's the same.
So Dan, exactly this picture. Now it's not just about a bug in your workload. It's a bug in your guest kernel, bug in a BIOS, bug in this QEMU in firmware. That's the whole point. You are not protected from any of these bugs in any of these systems. That's what we want to make sure we highlight. And the only way to avoid it is to reduce these number of layers that are running in CVM. And I think we can say that there is enough effort happening in this CCC towards those lightweight, like Coconut is doing it now, Grameen, and we have other projects like Google project, whatever getting the name now. But anyway, so I think if you can just mention where you have that workload, you can just mention and rest of the components running in the CVM. That will suffice. Right? Yes. So to introduce within the trusted workload, 1 second. So within the trusted workload and within the TCP. Yeah, you can say that. Guest.
How's that?
Yeah, I mean that at least maybe no one will notice it, but it at least captures the point.
CB. Okay, so I don't want to introduce terms and then have to define them.
Yeah.
So.
Or you can just say introduced within you don't use TCP anyway, right?
I guess not.
Within the within the TE boundary. Yeah, I think that's better. Yeah.
And is it a trusted workload or the workload itself?
I guess trusted is just emphasizing like this is the thing that you're relying on. So it's not if yeah, I don't know. Does it make it less clear to have the word trusted or more clear?
I mean, we can just say workload, I think.
Fewer words, always better. Almost. Alec, your hand's up. Sorry, I don't know if.
No, first off, I agree with everything that you guys have done, and I love these changes. I think make this better. I just kind of want to point out that from a technical perspective, this all makes perfect sense. There's another aspect of this, and that's from the customer perspective, that they're not necessarily needing to know if there are bugs in the TCB. They just want to know who owns the TCB. And so if you're a big bank and you want to put your workloads on a public cloud, you want to know who owns that stuff, right? Like if there's a big problem, you want to know the pieces that you're responsible for. And for, payment card industry stuff, you have to certify to them, hey, these are the pieces that I own. These are the pieces that the cloud service provider owns. And the ability to measure a workload answers that question, right? You can say, all right, these are the pieces that I own, and I know for a fact that they haven't been tampered with. I don't know if there's bugs in here, but I know if there are bugs in here, they're my responsibility. If there are bugs in this other stuff that isn't mentioned, go talk to the cloud service provider about those. They're not my problem. So just establishing a measurement so we know who owns what is super useful for regulated industries, and that's one of the big benefits of workload measurements. It doesn't reduce the number of bugs, Mona. I agree with you there. And we have equal number of vulnerabilities, and we have equal doubts in how trustworthy this stuff is. But at least I know that the problems are mine.
Yeah. And also how practical are those transparency logs? I mean, are you able to maintain through all the updates and all that? Is that practical? Because historically, I'll tell you with SGX, everybody, this whole MR signer and MR enclave, like where you actually compare a good known value, no one really could maintain these good known values because it was so constantly changing. And so they just always resorted to verifying that it's signed by a good part, third, whatever, a known signer. But I know Microsoft has done a lot of work in transparency logs, I guess Google as well. Is that does that look practical where you are able to maintain those as you're updating the operating systems, and how often are they being updated and how often those good known values are changing? And how do you even make sense out of it? I'm trusting somebody to say these, I don't know how so many things that it compares to good known value and it's good.
No comment.
I just want to know. Yeah. Okay. So I think that's
want maybe
so
Mona, I
that's
want
why
to answer.
whole,
Yeah, go ahead.
Yeah. No, I was just quickly. So while this document it's a really good direction that attestation is very important. And then we should have another document highlighting how hard the attestation is. And can we actually make it useful? Or is it just we're taking all these claims and we can't really make much sense out of it? But yeah, go ahead.
Yeah, so few thoughts about that, and I agree with you on the high level about the software measurements. How can you really prove it? Because it's just a number. But one, we have customers that are using our solution and use the software measurements as a way to identify good versions, that secrets are getting released to via based on remote attestation. So this is being used, and it is still valuable as long as you trust your CI environment where you build it. And the signing key is, yes, it's signing the enclave is good and makes it easier, but there are some customers that say, no, I want to have a deeper control. I think that the main question that comes here is, how do the different parties trust those measurements? So if you talk about a data clean room where we have customers that are using the solution and releasing sensitive information via remote attestation, this is where this question is getting opened and how you review the code and stuff like that and have a repeatable build. But having said everything that you said, running in confidential computing is for sure more secure than not running in confidential computing, and running with remote attestation, even with all of the challenges that you mentioned, is more secure than running without. So we should accept that the world is not perfect, but we can make it more secure with the tools that we have today, with all of those open questions and issues.
No, so exactly. So I was just saying that in this is a good document which is what you just said. No, attestation is better than no attestation. And then we can go into another document describing how attestation has its challenges. And then we could also have this whole TCB argument maybe in a separate document that could be that more focused on not attestation side of in raising the bar, but TCB size argument of raising the bar, something like that. But yeah.
And I think that what we discussed before and is reflected in the document is that confidential computing without remote attestation is not confidential computing. You cannot have just data in use protection.
Okay, great. Well, I'll see in chat Simon has some text there. I'm trying to think of the word for when we log things and then somebody can later go back and audit. It's like a compliance auditability thing. So we could make a compliance or auditability claim in section 2 here, where we're saying that gets to what Alec was also saying, I think, about you've got, we wouldn't put it this way, but you know who to blame. Like responsibilities are more clear.
Yeah, it's normally attribution or attributability or something along those lines.
Attribution and auditability.
Yeah.
Okay. Is that enough? Okay. So we have so few voting members left. I was going to suggest that we vote for those of us who are here, but I think we're down to 2 or 3. Maybe 2, 3, including me, I guess. So we need 5. So maybe we'll just do it to the mail list. So let's do that. So I'll do a call for vote on the mail list. And then we have a little bit of time left. Renee and Simon both did a lot of work. Who would like to crack open a document next?
I'm happy to open up our blueprint C.
Can I just ask for something in relation to these 2 blueprints? I guess that the answer is yes. Thank you. In Renee's document, I think that it is C. There is a good section that talks about confidential clean rooms ISVs, and I wonder whether we could have something like that section for Simon's blueprint. I didn't want to add it, aggressively, but I think that this is the best place for ISVs like ours to include their and introduce their solution, and it is ISVs. So if we have that, green light for the clean rooms, can we have that for the other document?
So we don't yet have the green light for this. We'll use this as a test to make sure that our LF advisories are supportive of it. And then if that checks out, then yeah, let's go ahead and add that sort of thing into the other documents.
Cool. Thank you.
A bit of a similar discussion around should we repeat a section or a few paragraphs about what is confidential computing in each blueprint, right? Dan, I know we had that discussion just a little bit above, yeah.
Mm-hmm.
Or so should that, yeah, right here. Should each blueprint be self-sufficient with this kind of 2-3 paragraphs, or should we just point to CC definition doc or something similar? I can see both pluses and minuses, right? Obviously adds extra text to already pretty long document. On the other hand, it makes it also self-sufficient.
Yeah, I mean, I would suggest we have that standard boilerplate text across all 3 docs, because what will happen with these, right? They'll get exported out to PDF and they'll be used as standalone docs, right? And I think that would probably make the most sense.
Overriding Dan's concern.
That's my input anyway.
That's the best kind of input.
Yeah, because I mean, you know how these things that go, they'll ultimately get, they will get passed around as a piece of content between people will email those docs around, they'll get shared, and it's very difficult where if we keep cross-linking everything, I think the context quite often gets lost. Someone will misread something in the rest of the document because they haven't gone and clicked on that link at the beginning of the document. So I think it's kind of almost really important just to make sure it's doubly reinforced, what it is that we're talking about.
Mm-hmm.
Yeah, I agree.
Maybe we could still condense it though to a paragraph instead of 3. I mean, they're already kind of short paragraphs, especially the first one, but maybe we can condense it to 1 paragraph and then link to the technical. I always forget what we call it, but our TAC white paper that we had up at the beginning of the meeting.
Okay. I'm just adding a comment for myself.
Oh, okay, great.
Okay. Other changes here mostly address the feedback. I did make the use cases significantly shorter. And another topic that I think we skipped previously, it was the attestation of the business logic versus attestation of the clean room infrastructure itself. So do the parties just know and agree on what business logic they're going to run inside of the clean room, or do they also attest or somehow have visibility into the clean room code itself as well? So I've added that. I think that was a little bit more fuzzy in the past.
Do you want to point me to a section, or do you want...
Yes, it is.
Or if you would like to drive directly, you could always share and I'll stop sharing.
Oh, well, I can do that. See. So this was, I wanted to make it very clear. And there are multiple approaches there, right? Why would the customer of the confidential clean room trust the provider, the ISV, or whoever is providing it? With obviously open source like Manatee, that's easier. Yeah, so folks take a look at that. Feel free to comment. other than that, I think it should be ready. Mengshen also added kind of a few simple diagrams or graphics to make it a little bit more visual. Nothing as fancy as Dan's visuals, of course. I also played with some Gen
Just
AI.
on Renee, on that comment,
Yeah.
on that additional text, I think that the key thing to decide what do you need to trust is what's running in the TEE. If it's it could be a combination of the workload that is coming from a code provider or model provider or whatever, and a code that is a part of the infrastructure. So
Exactly.
so you need to understand if what's running, everything that runs in the TEE, you should trust.
Yeah, exactly. But I feel like we haven't delineated initially between the business logic and the data clean rooms code itself.
I agree, but what I'm trying to say is that you can clarify. There are different solutions. Each solution implements the data clean room with TEEs in a different way. But what's important is that you need to create a trust in everything that runs in the TEE, and it could be both. It could be.
Yep. I agree. So that's what I tried to define here, because it's there's kind of the different levels of trust to on that code that is possible in different arrangements for different, depending on an ISV. But feel free to clarify this if it wasn't clear.
Yeah, I'm good with it. I'll resolve my comment here.
Okay. Anything? So because that's, I think, one of the limitations, essentially. Also add the kind of a threat here, threat model. Try to reduce the marketing here. Yeah, but I think it's ready for the approval.
That's great. I was just catching, there was a note from Jens about adding a limitations section. Do we have limitations documented in here?
It's documented throughout, not in a separate section, but Jens is on. Happy to have Jens add something separate there. Can ping him on Slack.
Yeah, no. Okay, great.
Awesome.
All right. Well, I think this, so if you want to send a note to the list that this one's ready for final approval, then we'll get people to look at it with that context in mind. And then Simon, we've got a few minutes. I don't know if you want to crack open either of yours.
Yeah, just give me 2 seconds. I've just had to remember how Zoom works. Hang on, I think it's that one. So you should be seeing Blueprint A.
In a moment, I think we will.
Okay, so obviously, I have yet to resolve the comments on Blueprint B, but I'll try and get that done in the next couple of days. But I did have some time, so I took a stab at the Blueprint A content here. So there are, just a couple of disclaimers, I guess, up front. So there are a number of diagrams in here. So these are all generated using Copilot. So it basically took the descriptive text and turned it into a diagram. I think the intent is that I'll turn those into a real diagram, but I find that a really helpful way of taking your first stab with making sure that the text relates to what it should be. So no particular artistic skill involved in those. So what I tried to do was go through and based on the feedback from the other blueprint, I tried to make this as kind of generic as possible, right? So obviously the feedback I think from Blueprint B was that it was fairly focused on Azure services, which is fair, obviously, given where I work. Sure. So what I started with was our kind of Azure content, and I spent some time trying to refine that into much more generic content here. So obviously, usual kind of stuff. We kind of outline exec summary, the overall intent of what we're trying to solve with Blueprint A. There's a piece on scoping. There is a kind of reference architecture diagram, which, okay, turned out kind of okay, but I think we'll probably need some work. Flow diagram for this piece about claims. But the thing I did want to kind of bring to your attention, so there is at the moment a big section in here on attestation policy. Now, I mean, I think this is important to have in here to cover. I think at the moment it's too big though, right? So, and obviously, and it started out as a fairly small piece of text, but got blown up pretty quickly when I kind of started editing it into the various bits and pieces of attestation. So I guess I was looking for a view of whether we either, I think what we're probably going to have to do is boil this down to much more brief content, but I think this is almost a document in itself, right? If we wanted to go into what is actually possible and maybe what some of the best practice around attestation policy is. So I think what I would boil it down to is chop everything out except for the kind of what you can control with attestation policy. There's a whole bunch of kind of example references in here, and I think these I'll just collapse down to being links to, which are actually at the bottom, these examples here, across the various hypervisors, across the various hyperscalers. And so what I tried to do was pick an Azure example, which is obviously fairly straightforward for me, a GCP example, and there's an open source example for each of these. And I've tried to repeat that through the doc. So again, with that kind of view in mind of trying to make it as generic as possible, whilst not trying to say, here's a recommendation of one. So hopefully that makes sense. So like I said, I think this will collapse down much more in the document. The comparison summary, I think maybe will get dropped out to a different doc. So I think it's less relevant to what we're talking about here. There's a section on security risk considerations, and I ended up only really putting a bullet point in. I think we want to turn a bit more into what some of the patterns we're trying to mitigate with replay attacks. I then tried to do out these very simple. I started out with a whole bunch more complicated ones, and I tried to pare it back as much as possible to these three patterns. That the diagrams don't render, unfortunately, particularly well in here, but it's essentially taking those kind of various patterns through. Then based on the kind of, I guess, the template that we started with, talked about kind of enterprise integration points. And for me, I think I like this, and I think I'll probably go and actually try and retrofit this to Blueprint B, because I think boiling it down just to the bullets for the individual pieces probably makes the most sense. And then I started to think about how an organization might try and actually do this for real, right? And I think that's really what we want to try and do here, is to try very simple. And again, this is one of those things that started out very verbose and got deleted very quickly down into individual bullet points for how someone can implement this. And then I have a set of references in the end here, which I think are actually a little bit duplicative of some of the things that are earlier on the document. So again, I'll try and chop those down a bit more. But the one thing I did want to show is, and to be completely honest, the control mapping here was all done with Copilot, right? So, which is, I find, really useful for kind of comparing large corpuses of controls text for things. And it's actually done, what I think is a fairly good job of looking at what the relevant frameworks are, and more importantly, picking out the individual directives from those various frameworks against some of those kind of capabilities. So I think this is actually quite a useful piece for this document, and I don't know whether it's something we want to consider for some of the other patterns, because I suspect many people who are looking at this are going to have those kind of control mapping or capability mapping type requirements. So it's one of these things, right? You could go into massive depth on it, but I think a table like this is a really simple way for someone, who's looking at confidential computing on one hand with a requirement to implement, I don't know, some kind of access control mechanism. It's a simple way of saying, well, I can satisfy, requirement X using this feature of confidential computing. some boilerplate down the end. So at the moment, it is still a little bit raw in here, but I kind of thought it was better to start with, content that we could all kind of collaboratively or directionally say yay or nay, and then we can kind of trim down and work to. So that hopefully that makes sense as a very quick walkthrough. But I welcome, comments in the doc, and I can obviously address those asynchronously, given we've only got 5 minutes.
This is fantastic, Simon. This is a ton of work that you got into here. It's great. I look forward to going through it.
Cool.
All right, I think that's probably a good stopping point for us. We got introduced to Blueprint A and checked in on C, and we're ready to go forward with the 3 degrees. So, Alec, you are saying something I really want to hear.
You're going to reconsider as soon as I say it. The little table that you had, Simon, on the different controls and which ones are relevant for Blueprint A, I think all of those apply equally to all of confidential computing, right? It's not specific to any particular model, right?
Potentially, yeah. Like I say, I mean, some of that's kind of derived via LLM, so I'd have to take a little bit more look at it in detail for that. But yeah, I mean, maybe that's something we break into a separate.
I mean, I've been messing around a little bit
to the SIG folks, yeah.
I've been looking at the ISO ones specifically and the CCA ones specifically, and it seems like just broad brushstrokes, they apply equally to all of confidential computing. So we might want to bubble that up to sort of the terminology paper or something that's less application specific and more applies equally to all of confidential computing. I'd never thought of that, but that's a really cool table.
Yeah, and I think that's a good way of doing it, because if you think about the kind of entry point to a lot of this, if there is someone who is a GRC type person in an organization, I need a solution for requirement X, right? The Googles or the Bings of the world are where they hit for those things. And if we can have that kind of control mapping, or how we satisfy that part of a control mapping, I think that's a really good kind of way of signposting.
Yeah, and being in the regulator space, I'm approaching it strictly from the point of view of people who have never heard of confidential computing, but they're ISO folks, right? And they follow ISO instructions and they come upon a term, then that's exactly right. That's the first time they'll have heard of confidential computing. So I think that's exactly right. So let's maybe surface that to a bigger doc.
So do you think that's worth giving to the SIG? I mean, I haven't attended any of those SIG meetings, but that potentially, I guess, falls into some of their territory as well, right?
I haven't attended the SIG meetings either, the GRC one yet. I'm not exactly sure. I'm looking at it more from the ISO, GRC kind of membership. And I honestly, since all the documents are owned by the TAC, I think we can just include that in any of the TAC documents. We don't have to go to those. I just was probably going to lift your table and stick it in a higher level doc if it's good, once the rest of the TAC approves it. I just really like the format. I'd never seen that before. I've always wondered, when we were working with the Cloud Security Alliance, they were basically trying to say which of these controls apply to CCC, and we never dug it out. And that table kind of answers those questions. I'm getting the same questions from ISO.
All right. Well, good use of the last few minutes here. So we will call it a day, or at least call it the end of this meeting, and continue the discussion on Slack and the mail list. See you all in 2 weeks.
Great. All right. Thanks, everybody.
Thanks.
Cheers.
Bye-bye.
Thanks, Dan.